Mr. Balmes, kindly lead the prayer.
Our Father, who art in heaven, hallowed be thy name, thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses as we forgive those who trespass against us, and lead us not into temptation, but deliver us from evil. Amen.
Good morning, class.
Good morning, sir.
Please arrange your chairs properly and pick up the pieces of paper under your chairs. And take your seats.
Thank you, sir.
Class secretary, is there any absent today?
None, sir.
Okay, very good. Last meeting, I gave you an assignment about the resistance, voltage, and current. Now, get your assignments, pass to the center, and then forward. So class, before we proceed to our discussion for today, let's have a short recall about what we have discussed last meeting. So Miss Marana, can you tell us something about our previous topic?
Yesterday we discussed about resistance, voltage and current. Voltage is an electrical pressure that causes electrons to flow around the conductor.
Okay, very good. That was excellent. Class, did you have a question about our previous topic?
None, sir.
Okay. So now, let us proceed to our new lesson. But before that, I prepared a short video clip that is related to our today's topic. So, do you want it, class?
Yes, sir.
Okay, did you enjoy watching, class?
Yes, sir.
So, who among you has an idea about our lesson for today? Yes, miss?
Sir, I think our lesson for today is all about Ohm's law.
Okay, very good. Class, our lesson for today is all about Ohm's law. For us to be properly directed in discussing our topic, let us first read the objectives of the lesson. So, at the end of the lesson, the student must have state Ohm's law, appreciate the importance of Ohm's law in real-life context, and calculate each variable in Ohm's law. So, what is Ohm's law? In 1826, a German scientist named George Simon Ohm discovered the relationship between current, voltage, and resistance, and the result was Ohm's law. Ohm's law is one of the principal laws in the study of electricity, which states that the greater the voltage is, the greater the current will be. However, if the resistance is high, the flow of the current is affected. Thus, it tends to become small. Hopefully, by now you should have some idea of how electrical voltage, current, and resistance are closely related together. So, the relationship between the voltage, current, and resistance forms a basis of Ohm's law. In a linear circuit of a fixed resistance, if we increase the voltage, the current will also increase. And similarly, if we decrease the voltage, the current will also decrease. This means that the voltage is directly proportional to the current. On the other hand, if we increase the resistance, the current goes down for a given voltage. And if we decrease the resistance, the current goes up. Which means that the resistance is inversely proportional to the current. Then, we can see that the current flow around a circuit is directly proportional to voltage, but inversely proportional to resistance. I have here a table that represents the symbol, unit of measurement, and abbreviations of our three units, which is the resistance, voltage, and current. For resistance, the unit of measurement is ohms, for voltage is volts, and for current is amps. And now, let's jump to another topic, which is the computation of the three units, which is the resistance, voltage, and current. Is triangular mapping for me. So this triangular mapping is a great technique to figure out what formula that you can use. For example, if you look at the formula for voltage, just place your finger into the symbol of A to the triangular mapping or voltage, and basically you already have a formula that is I times R, or ampere times resistance. And if you look for ampere or capital I, just point your finger into the symbol of I, and basically you already have or know what formula you can use in ampere. So that is V divided by R, or E divided by R, or voltage divided by resistance. I have here a example for better understanding. So, how much current flow is present in a circuit having a resistance of 7 ohm and a voltage of 13 volts? Step number 1, identify the given. So, which is the 7 ohm, 13 volts, and the current flow, which is the what is asked in the problem. By simply identifying those given, you can easily identify what formula you're gonna use. And let's try also the triangular mapping. So point your finger into the current symbol, and basically you have a formula, which is the I equals E over R, or voltage divided by resistance. So step number 2, substitute, then divide 13 by 7. The answer will be 1.87 amps. So don't forget to write the unit of measurement. So for the application, I will give you a short individual activity. So before we start, let me first explain the activity that you are going to do. So direction. So as a motivated student, you can be a future teacher. You are assigned to make 2-word problems on voltage, current, and resistance. It should have complete details and follow the examples below. So use extra sheet of long band paper. So this is the example. So calculate the current. An electric clothes dryer draws when it is connected to a 230 volt source and has a resistance of 9.2 ohm. So write the given, the formula, and the solution. And also the answer. So did you get it, class?
Yes, sir.
Are you ready?
Yes, sir.
Are you done, class?
Yes, sir.
Okay, so pass your activity to the front. Okay, to sum up our discussion for today, what again is Ohm's law? Yes, miss?
Ohm's law is one of the principal laws in the study of electricity, which states that the greater the voltage is, the greater the current will be. Also, the relationship between voltage, current, and resistance forms the basis of Ohm's law.
Okay, very good. So what do you think is the importance of learning the Ohm's law? Yes, mister.
In order to protect a circuit, fuses and circuit breakers are used. These are connected in series with the electrical appliances. Ohm's law allows us to find the value of the current which could flow through the fuses.
Okay, very good. It seems that you really understand our lesson for today. So for our evaluation, get 1/4 sheet of paper and answer the quiz. So for the direction, answer the following voltage, resistance, and current problem using the following format below. And put a box on your final answer. So for number 1, number 2, number 3, number 4, and number 5. Are you done, class?
Yes, sir.
Okay, so pass your paper to the front and get your notebook, then copy your assignment. For your assignment, this is the direction. So make a research on sources of electricity in our country. Okay, so are you done, class?
Yes, sir.
Is there any clarification?
None, sir.
Okay, very good. So have a good day and goodbye, class.